Hello dear students, welcome back. Our today's topic is functions for A levels. You can go and look for the video on functions for O levels at my channel, and you must go through those videos. But here I will give a very rapid and brief recall of evaluation and finding inverse of a function in this lesson, and we will then move further. First of all, we will learn that in O levels, we learned about evaluating a function. Suppose f of x is a function, f of x is equal to 3x plus 4. We can also write f is a function from x to 3x plus 4. These are two different notation used to write a function. F of x is this, and we want to find the value of f at x is equal to 1. For that, we will replace x by 1 and then simplify it. Similarly, if we want to evaluate the function at x is equal to 0, in this expression, we will replace x by 0 and hence we will get this is 4. F of minus 2 is equal to 3 times minus 2 plus 4, which will be minus 2. This we actually learned in O levels as well, but here I am just giving it a recall. Second point which we learned in the previous class, O levels, that was finding the inverse of a function. Let us go through the procedure of finding the inverse of a function. Suppose y is equal to f of x, which is equal to 2x minus 3. And we want to find its inverse. For that, first of all, what we will do, we will write y is equal to f of x is equal to y, and then we will solve this equation to find the value of x. Like I did over here. And then in the second step, in the first step, f of x will be replaced by y, and this expression will be used, this equation will be used to find the value of x. In the second step, x will be replaced by f inverse of y. And in the third step, y will be replaced in this equation by x. So f inverse of x is equal to x plus 3 over 2. So this is the inverse of a function, this. These two are inverse of each other. If we put 3 over here, if we put 4 over here, we will get 5, and if we put 5 over here, we will get 3. Here, if I put x is equal to 4, I will get y is equal to 5. And here, if I put x is equal to 5, I will get y is equal to 5 plus 3 over 2, 4. So these two functions are inverse of each other. So in short, I just recalled two things. How do we evaluate a function for a given value of x? We just simply replace x by that value in the expression. And secondly, we have learned that how do we find inverse of a function? There are 3 steps. In the first step, we replace f of x by y, and from that equation we find the value of x as we did over here. Then we replace x by f inverse of y, and finally we replace y by x. This is how we find inverse of a function. To see the detailed examples, you can scroll in my channel and find functions O levels lessons, and from there you can get different examples to master the concept. The next thing is composition of a function. Again, we learned the same in O levels. I will give the links of the videos on this topic in the description of this video. So from there you can go and watch the lessons. Composition of a function. We can compose a function f on g, we can compose a function g on f, and we can compose f on f, and we can compose g on g. Let me give an example over here. For example, f of x is equal to 2x plus 1 and g of x is equal to x plus 5. And I want to find f of g of x. This is called composition of f on g. For that, we will simply replace x by g of x over here. F of x is equal to 2x plus 1. F of g of x will be 2 times g of x plus 1. In the first step, in f of x, we will replace x by g of x. And in the second step, we will put the value of g of x and simplify. This is f of g of x. On the other hand, if we want to find g of f of x, what we will do? In g of x, we will replace x by f of x. And in the second step, we will put the value of f of x and simplify to get the composition of g on f of x. In some books, it is also written as fg of x, and this is written as gf of x. Now, composition of f on f. F of x is equal to 2x plus 1 over here. F of x is equal to 2x plus 1. F of x is equal to, f of x was 2x plus 1. F of x will be 2 times f of x plus 1, and we will simply put the value of f of x and simplify it to get the result. This is f of x. Remember, this is also written as f square of x. Similarly, g of x will be, g of x was, what was g of x? X plus 5. So g of x will be g of x plus 5, and this will be x plus 5 plus 5. After simplification, this will be x plus 10. This is called g of x, also written as g square of x, also written as g of x. So this was the composition concept. Again, we learned this concept in O-levels lessons. I have given the links of those lectures in the description of this video. You can go and recall that. Next is the last part of our this lesson is range of a function. Range of a function. Basically, function is a machine in which we put some values of x, and in return we get output values of y or f of x. Let me give an example over here. Suppose f of x is equal to x square. These are values of y. And you can easily understand that this x square can never be negative. It can only take up values. It can be 0 at x is equal to 0, and 0 is its least value, and all other values will be greater than 0. So in this case we say f of x is greater than equal to 0. This is called range of f of x. Graphically, from the graph, range basically is the term related to the values of f of x or y. F of x is equal to y. So here, let us understand this concept with the help of few graphs. This is the graph of f of x is equal to minus x plus 2, this line. You only need to see that along y-axis, where does graph go? You see, as long as x goes on increasing, y goes downward. So it takes up every negative value. And as x is decreasing, y goes upward and it takes every positive value. So the range of this graph is from minus infinity to infinity. It is written as f of x belongs to real number, or y belongs to real number, or minus infinity is less than y is less than infinity. There are several ways of writing this. But if when we move to this graph, the second type, you can easily observe that the least value of y is 4 over here. This is the least value of y, 4. Y cannot go below 4. So range of this function will be f of x is greater than equal to 4, or y is greater than equal to 4, or we write 4 is less than equal to y. Same thing. And if we go to our third graph, this is a rational function, f of x is equal to 1 over x. You see, here y never touches x-axis. That means y is never 0. Y is never 0. It never touches x-axis. It can never be 0. We can make it as small a positive value as we wish by increasing the value of x, and we can make it as small a negative value as we wish by decreasing the value of x, but it will never be 0. So its range is all other values. Y is going upwards, y is going downwards, but it is never touching this x-axis upon which y is equal to 0. So range of this polynomial is y is not equal to 0. All other values except 0. Similarly, this is 2 raised to power x, an exponential function. From here, you can easily observe that as we go on increasing the value of x, y is going upward. And as we go on decreasing the value of x, y is coming downward. But it will never be negative. Excuse me. F of x is equal to 2 raised to power x. Whatever are the values of x, 2 raised to power x is never negative. For example, if x is minus 3, this will be 1 over 8, 0.125. If this is minus 5, x will be minus 1 over 32. Again, a very small number, but it is positive. So y is coming down from infinity. It goes on decreasing, and at x is equal to 0, it is 1. As x goes becomes negative, it goes on decreasing, but it will never touch this line. So range of this is y is greater than 0. There will be no equal to, or 0 is less than y is less than infinity. Or we can write 0 to infinity interval. But 0 is not included over here. So this is the concept of range of a function. Last example of this section. This is f of x is equal to log of x, common log. Y is equal to log of x, also written as log of x to the base 10. You see its graph. It never touches y-axis. It means over here we cannot put the values x0. Log of 0 or negative number is not defined. This is the concept of domain. We will discuss it in another lesson. But we see over here, as x goes on increasing, y also goes, although this process is slow, but y also goes on increasing. So this is a function which takes up all the values, negative and positive. So range of this function is minus infinity to infinity, or we can write it minus infinity is less than y is less than infinity, or y belongs to real number. This basically was a bit of understanding regarding the concept of range, or finding the range, or understanding the range, or calculating the range from the with the help of graphs. Now we are moving to our special part of this topic, range of quadratic function. This is very important. In our quadratic lesson 1, I will again share the link of the video in the description. We learned two different types of graph of parabola or quadratic function. First one was opening upward. This was when coefficient of x square is positive, and second one was opening downward. This was the case when coefficient of x square was negative. So from that concept, we easily see, read this carefully, range of a quadratic function written in standard form. This standard form we are going to discuss soon. With a positive value of a value, with positive a value is f of x is greater than equal to k, and with the negative a value this is less than equal to k. Let me clear it a bit. Look over here. This is the graph of a quadratic polynomial of first type. Okay, this will be a function like this. F of x is equal to ax square plus bx plus c, but a will be positive. In this case, we do have a minimum value which is 5 over here, but we don't have any maximum value. So its range will be f of x is greater than equal to 5 or y is greater than equal to 5. In this case, f of x is equal to ax square plus bx plus c, where a is negative. The graph will be opening downward, as you can see over here. In this case, the maximum value of y is 7 over here. So y is less than equal to 7 or f of x is less than equal to 7 will be its range. It was basically meant by this paragraph. This was meant by this paragraph. So if the quadratic polynomial is of first type, this will be the range, and if it is second type, this will be the range. Now let us learn finding this value with the help of few examples. For example, I have a function f of x is equal to x square plus 7x plus 12, and I am asked to write its range. Let us make it 8x. So first of all, I will complete the square and I will write it as f of x. I will take it to the standard form. X square plus 8x. Half of 8 is 4. 4 square will be added and subtracted. So this will be x plus 4 square minus 4. So I have converted into a times x plus 4 square plus x plus b square plus k, suppose. What is k in this case? Minus 4. So this is a quadratic polynomial of first type because coefficient of x square is positive. This is converted into standard form, and when we convert it into standard form, k is equal to minus 4. So its range will be f of x is greater than equal to minus 4. Let us go to another example. See over here, f of x is equal to 5 minus 8x minus x square. Here coefficient of x square is negative. So what will I do? I will take minus common and I will get this. We learned this in O levels quadratics, A levels quadratics lesson number 2. Link will be again given in the description. How to convert a quadratic expression into standard form. I am rapidly performing the function, the operation. So what is the value of k now? It is 12. But since coefficient of x square is negative, graph will be opening downward. This 12 is its y coordinate of its vertex, but this is its maximum value now. So f of x will be less than equal to 12 or y will be less than equal to 12 will be range of this quadratic polynomial. Dear student, this was all for today's lesson. I have given some videos in the description. Do also listen to those lectures. I hope those lectures along with this would be sufficient to help you understand the concept of evaluating a function, finding the composition of two functions, finding the range of a quadratic function, inverse of a function. Inshallah, in next class, we will move forward to the further details of functions for A levels. Please do subscribe this channel for timely notifications of upcoming videos. Stay tuned. Allah Hafiz.